Hi, this is Algebra 1, Module 4, Lesson 2, Practice Problems. Um, we'll go through these most of these so you can review how you solve for different variables. So to start with, we're going to do solve for x. So we're isolating the indicated variable over here, and we're going to say what we're going to do first to be able to do that. So if it's ax equals 7 and I want to solve for x, then there's multiplication between the a and x. So that means to get the x by itself, I need to divide by a. Next one, I want p by itself. So if I want to get p by itself, I'm adding an 8 to it. So to get rid of a plus 8, I need to subtract 8. Again, it's just practicing that um, undoing piece. So here we're solving for m, e equals mc squared. So to get the m by itself, I need to get rid of a c times c squared. So to do that, I need to divide by c to the second. Okay, solving for t. These I think you're going to do okay for a little while. Let's go down to this 8. Solving for y. So it's a times half. Well, we've been saying up here to get rid of a times, we divide. But dividing really means multiplying by the reciprocal. So the reciprocal of 1/2 is 2. So I actually want to multiply by 2 to be able to cancel out the half. Same thing on 9. Solve for h. Well, h is up here. It's in the numerator. Remember how in the notes we made the comment that b over 2 is really kind of a fraction multiplied by h, right? b over 2 times h over 1 would be bh over 2. So to get rid of a b over 2, I can multiply by the reciprocal, which is 2 over b. Multiply by 2 over b. You also could say, I'm going to multiply by 2, then divide by b, which is really what we've done right there. Solving for x. So this one is a two-stepper. We actually have to do two things on this one. Because it's not a fraction that we can just do it in one shot, we have to get rid of the b and then get rid of the m. So I actually need to start by subtracting b, then I can divide by m. So that one we have to do two steps because you can't do that all in one shot. Two different, completely different operations. All right. Defining and interpreting variables. So Jackson likes to be organized, so we made the following chart. He has decided to keep track of the miles he runs and the time he spends running. He attends PE class on Monday, Wednesday, and Friday, but goes to school every day. So fill in the units column on this chart. So number of miles ran in PE class on Mondays. Number of miles. Notice we've got our units. Notice we have our units really right here in this column. So these are all just going to go right over here. Number of miles. He ran 3 miles on Monday. He ran 4 miles on Wednesday. He ran 12 miles on Friday. Number of miles from Jackson's house to the school. It's 3 miles away. All those labels are going to be in miles. And then in these guys, we're all in time. It just depends on which time unit he's talking about. So time in hours to travel to school, that would be hours. But all the rest are saying time minutes. It takes me 3 minutes to run. I ran on Monday. I ran 30 minutes on Wednesday. I ran 45 minutes on Friday. So those are the labels that are going to go over there. So that's just practicing kind of your labeling. You should be labeling by this point anyway. All right. Make meanings of the expressions by writing what they mean. So we're looking back at our table up here. M plus W plus F. What does that mean? Well, that's the miles he ran on Monday, Wednesday, and Friday. So that's really his miles ran each week. 12. If those equal the miles he ran each week times 4 weeks, well, what unit of time is 4 weeks? About a month. So miles in a month. K2S. What's S? Let's look up here. S is the number of miles from Jackson's house to the school. Well, if he's doing it twice, he's starting at home, he's going to the school, then he's probably coming back home. So that would be a round trip run. We'll just call it a round trip because he's going from home to school, back to home. T of M, time spent running in Monday, time spent running in PE on Wednesday, time spent running on Friday. So that would be his time spent running in a week, right? Time spent running a week. We said those are the 3 days he runs. So far, these are all making sense. This one, here, let's move that up so we can see it a little better. All right. So what we just said, the time spent running in a week divided by 3. Well, he only really runs 3 days. So this would be the average, that out of the way, average miles, average time. We're talking about time. Average time running per day. Let's scoot that one over. He runs 3 days a week. He's taking his total divided by 3. That one works. All right, 5 times 2h. So time and hours to travel to school. So that's a round trip to school, right? His time going to and from school. Well, what does 5 stand for? Well, he goes to school 5 days a week, which is different from ours. But that would be his time spent traveling in a week. He's going to and from school. Let's put that one up. So that's his round trip driving, getting to and from school for a week. M plus H, number of miles plus the time it takes to go to school. Now, that one's a little different because one unit is miles and the other one is hours. So when we add miles and hours, that's like saying I have 3 apples and 4 oranges. How many oranges do I have? It doesn't make sense. You can't add miles and hours. So this doesn't make sense. Can't, just going to put that. Can't add miles and you can't add miles and time and call it all time. It's not all time. So kind of like our x's and y's. You can't add x's to y's and call them all x's. It doesn't work. Okay, next page. This one, excuse me. We're practicing, so we're pulling back a little bit of our set notations that we did in the second module. And then our interval notations we did in third module. So we're not getting rid of these entirely. Still looking at these. So interval notation. So interval notation means a bracket for I'm including it and a parentheses if I'm not. Well, I'm starting at -2 and I'm going all the way to 6. So I know I'm going to need those numbers because it's all real numbers in between. But I'm not equal to -2 and I'm not equal to +6. So I would actually do parentheses around each of these. So that would be the interval notation for that. Now, conversely, I want to do this one backwards. Well, if I'm doing all the numbers in between, then I know that um, I'm going to need x, and then out of there, x, and I don't have that symbol, so I'm just going to put a capital E in my case because I don't have that symbol on my keyboard. And I'm going to do real numbers. But I'm going to start with -4 because that's my first one over here. And it's greater than or equal to. So I'm, again, don't have those keys on my board. So I'm just going to write it this way. You guys would do the proper uh, less than or equal to symbol here. And then x. And then x is also, but is less than or equal to 7, end bracket. I have to kind of compromise a little bit since I don't have a greater than equal to symbol on my computer at the moment. So here I'm showing I'm going to start with -4. It includes -4. I'm going to go to 7 and it includes 7. Let's do um let's jump down to this one since we have the one parentheses and one bracket. Actually, we'll go ahead and do this one first because we only have one number in here. So I know that I'm going to use all real numbers, and it says x is greater than or equal to -9. So my lowest number, and I'm including it because it's equal, is -9, but then I'm going to go forever to the positives, right? X is bigger than this. So then I'd actually put infinity. And you can put the infinity symbol. Again, I don't have that on my keyboard, so I'm not able to plug that in at the moment, but we'll just do infinity on that. All right, next one. We have parentheses and a bracket. So let's start us off with our x. X is real numbers. We're doing. Okay, so 0 is what I'm starting with, but I'm not equal to it. So I'm just going to leave that symbol this time. And then I'm going all the way to 13. So it's less than x, which is less than, and this time it's equal to because I have the bracket, less than or equal to 13. And I can end my bracket, my little fancy brackets there. All right, this guy, we've got -15 to -8, both inclusive. So that's pretty straightforward. -15, comma, -8, and brackets. There we go. Same thing with this guy. We got one of each. So we can do x. X is all real numbers. And then -32 is my first one, and it's less than or equal to my x. But my x is just less than, in the space, -15. So just the one symbol there. And how about this one? What am I going to do for that when it's negative infinity all the way to positive infinity? That basically means I can use any real number. So x is real numbers, and that's it. All right, good review of that one. Which notation, interval, or set would be most appropriate when working with the domain of whole numbers? So to answer that one, which of these would be for whole numbers? We probably don't want to use interval because that includes everything in between. So really, if we're going to do a domain of whole numbers, we should use set notation because then we can say natural numbers or integers. And for natural numbers, Or I'll just put on here natural and specify. That's the word I want. Specify natural numbers or integers. I suppose in all reality, if you're doing whole numbers, you didn't specify if they're positive or negative or both, you would technically use integers. But we definitely cannot use real numbers, which is what we need to use when we're doing interval notation. All right, last couple. For each of the inequalities, provide a graph provided. For each of the inequalities provided, graph the values being described on the number line. So x is less than 6. So I'm going to draw a few lines on here. We'll go ahead and do them in black. One in the middle. Let's just do, we're going up to 6. Let's just make that 0. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. As long as I mark them. And then I want it less than, so I'm going to put a circle on 6 because that means it's not equal to, and I need to point it towards the negatives. 27, it says we're going to 5, so 1, 2, 3, 4, 5. That was my 0. 1, 2, 3, 4, 5. Negative 5. So again, I have green will go every other. I have an open circle because it's not equal to 5, but it is greater than. So we're going to go that direction. Negative 9. We have to get to negative 9 this time. So I'm going to go ahead and put my 0 over here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And this time I want a closed circle because it is equal to. So I'm going to close my circle. And x is greater than, so I'm going towards the positives. Here I've got a range I have to go between. So I need to make sure I have a 0 and I have a negative 7. Let's go ahead and we'll do 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so negative 7 is right here. It is equal to negative 7. So I want a dot on negative 7, but it is not equal to 0. So I want an open circle at 0. So one is closed, one is opened, and x is everything in between. No arrows on this guy. All right, 3 to 25. That's a big stretch. So let's count by twos. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. All right, so, 25. That throws off a little bit. It's okay. 2, 3. We should have a dot between 2 and 4 for 3. And then 2, 4, here's my dot for 25. Notice they are both equals. So it's a dot, and I'm doing everything between them. And my last one, negative 15 to 8. So let's, we'll put 0 kind of on this end. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I got them all to fit. Excellent. So this time I want, let's see, not equal. So I need an open dot at negative 15. This one is equal. So I need a closed dot on 8. And then I want everything in between. All right. Thanks for joining us. And we will see you next time.